I'm gonna record. So now it's recording, and we going to start with our lovely book, as I mentioned before. And here is the book. I have like a hard copy, but of course you guys already have a soft copy already shared on the Slack, right? So we're gonna repeat again whatever we mentioned about the binary, right? So this chapter we're gonna learn binary. We're gonna learn octal, and we're gonna learn hexa. Somebody want to get in hexa, and we're gonna learn whatever systems you can imagine. You can say Muhammad system, whatever. And we have on the other side we have decimal. And when we are talking about this, we're gonna talk about integer format and fraction format. Of course, when you have an integer with fraction, end of the day, you are talking about what? Real number. So if you have integer with decimal point here and fraction, you are talking about what? Real number. Then we're gonna start moving into the adding and subtracting and other things. Okay, let's start with the binary. So as we learned before in decimal, why decimal called decimal? Decimal because you already have 10 bases or 10 elements or like a space of numbers the decimal per digit is actually covering, right? So each digit can be one of the element in the following group. When we say group, we already have group of numbers 0, 1, 2, 3, up to 9, right? So 0 to 9, how many numbers we have? We have 10, right? So that's why 10. Interesting. You keep adding and go. Anyway, 10, right? So if we look to any number in general, it's gonna be digit 0, digit 1, digit 2, digit 3, up to digit n, right? And then if I look to the power of the digit, it will be 10 power 0, 10 power 1, 10 power 2, 10 power 3, up to 10 power n. So this is the power, the location, right? Then whatever number in the digit is called weight. So whatever number in the digit is called weight. So if you like to make an equation, just make an equation, right? About how this can look like, you can come and say that, the total is equal to d 10 power n time wn plus 10 power n minus 1 time wn minus 1 up to the 10 power 0 time w0. What is this w0, wn, whatever? Are numbers. Like example, I have a number, say 358, which is 358. So let's actually map it to whatever I mentioned. So we already have here D0, we have D1, we have D2, right? So let's look at more. Air Force One. Anyway, so if you go into the total, that will be 3 times 10 power what? 2, right? Plus 5 10 power 1 plus 8 power 10 power 0, right? Which is basically what? 300 plus 50 plus 8. So you're talking about 358. If I understand this concept, the rest is going to be a piece of cake. Okay? So this is something I have to understand. If I go into a binary, let's say binary now, binary. Binary, since it's called binary, so I have a space of numbers, which is 0 and 1, right? So the numbers I have covered by this is actually 0 and 1. How many of those elements we have? 2. So my base, the official base of the binary, 2. So it's gonna be B0, B1 up to Bn, right? And this is what 2 power 0, 2 power 1 up to 2 power n. And we're gonna do the same thing with weight. That makes sense? Let's go into octal. So octal is going to be 0 to 7. So that means my base are 8. So it should be what? It should be O0, O1 up to On. And then A power 0, A power 1 up to A power n. Same thing for hexa. Hexa, that means I have 16 numbers, right? And these numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But I'm looking for a digit. So they came and say 10. It will be 2 digits, right? So they actually may start using what alphabets. So they would say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and what? A, B, C, D, E, F. Those are the 16 numbers I have. That's why, my thing is going to be hex H0, H1 up to Hn, and that's going to be 16 power 0, 16 power 1 up to 16 power n. Let's say, Dr. Ali came and say, I'm going to make Muhammad system. And Muhammad system is just like, 0, 1, and 2. And that's called Muhammad system, right? So going to be what? How many of those are 3, right? So M0 up to Mn is going to be 3 power 0 up to 3 power n, and so on. Sounds good? Now we are going into conversion. So let's take it one by one. I have decimal, I want it to be a binary, and have a binary, I want it to be decimal. Make sense? I have a something in decimal. So the decimal, like 358, the number we have, that's actually like this. Some books notation would say that I'm gonna write it 358, and I will tell the reader that it is in decimal, but put it in a parentheses and put it like a lowercase n. Then the people will understand this number is what in decimal. And what is exactly the question to you? Can you please convert this to me to be binary, or give me the equivalency of the binary system of this number? What you gotta do? So 358, it's actually in a tens base, but the binary in the what? In a 2 base, right? So rule said, if this number is integer, you have to keep dividing, and you are keep taking the numerator of the remainder from the top to the bottom. Let's see what is this, right? So 358, I'm gonna start dividing by 2. That's basically what I said. Why 2? Because I'm actually looking for binary. So I'm looking for the equivalence in binary. So 358 divided by 2. So to make it easy, I'll just use my phone, and it's gonna be 358 divided by 2. So you are talking about what? 0 power divided by 2, and here is 179. That means there is no remainder, right? Then I will take this quotient and I keep dividing. So gonna be 179 divided by 2. So that's gonna be divided by 2. So I have half. So gonna be half plus 89. Then I take my 89 divided by 2. So 89 divided by 2, it's gonna be 44, and I have half. Then I take the 44 divided by 2. That's really quite easy. So gonna be 22, and there is nothing here. And then 22 divided by 2, so gonna be 11, and nothing here. Then 11 divided by 2, So there's gonna be 6 here, and then I have half, right? No, 10, 5, I'm sorry. 5. Then I take the 5 divided by 2. So it's gonna be what? It's gonna be 4. So it's gonna be 2 plus half. Then I take the 2 divided by 2. So that's gonna be what? It's gonna be 0 on 2, and here 1. Then I close up when I see the 1 divided by 2. So it's gonna be like this. No more what? No more processing by divided by 2. So, because, think about it, right? 0 divided by 2, everything would be zeros. So far, so good. Any questions so far?
Professor?
Yes.
Could you please do it dividing it by 4? I just want to see.
If I divide by 4, then, I'm looking for the equivalency of the tens to the 4th system. You understand my point?
So that means if we're looking for binary, we're always going to be dividing by 2?
Yes, this is a rule. If you binary, you divide by 2. If you octal, you divide by 8. If you hexa, you divide by 16.
Oh, okay.
That makes sense? Okay. Now, it is a time for us to write the equivalency in the dedicated area, right? So if I go ahead and just clean up this and I start writing, we agreed that, I know that we are in English, we write from the left to the right. Yes, I understand that. But, we are now talking about math, right? And in the math, we know that the lower digit, it's in the left, in the right, and the higher digit, it's in the left, right? So the lower digit, this is the lower digit. So, if I'm gonna start writing whatever coming out, I will just go from the top to the bottom like this. And I will start picking the number from the numerator of the remainder. And I know for sure the numbers on the numerator are gonna be either 0, it can be 0 or 1. That's it. Right? So now here's 0. This one is 1. This one is 1. This one is 0. This one is 0. This one is 1. This one is 1. And 0. And 1. So I'm done. I found out what is the equivalence of the 358 in the decimal space and what is the equivalency in the binary space. To be sure that, somebody can ask you the reverse question, right? What is the reverse question? Here is the binary, and I would like to know what is the equivalency in decimal. Then we're gonna use the weighted system. Let's try it. So the key thing about chapter 1, at least chapter 1, is the practice. If you keep practicing, that will make it for you easy for the rest of the course. So let's take a copy of this and go ahead and do the reverse engineering work on it. So it's gonna be here 1 0 1 1 0 0 1 0. That was our number in the as I requested, and I'm looking for the equivalency in 10th. That makes sense? So in that case, I need to look to the regulation I made up here, if you guys remember. Do you remember this regulation? We're gonna use it now. So if I go here and say, this is the base, so 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Right? So that's saying that we need to know some information about this. I have here a number represented in how many digits? 1, 2, 3, 4, 5, 6, 7, 8.
Professor, sorry, I think you're missing
Yes.
another 1 after the second one.
Did I miss something?
It should be 0 1 1.
0 1 1.
Reading from the right to left.
You're right. So this is how
so-
many digits?
Total will be 8.
It
So
should be
two-
8, right?
Sorry, total will be 2 power 8. So
2
that'll be
power 8.
total.
2 power 8,
Yep.
you're right. So it should be 9.
Yep.
So we have 9 digits, right? In the system of electronics, we don't call it digits, we call it bits. So the digit is bit for us. And the bit can hold charge or not charge. So we can call this what? We have a binary number represented in 9 bits, and we are trying to translate it into a decimal number. Again, so this one can be written like this: 9 bits in binary, and I'm looking for the equivalency in decimal, right? So what I'm gonna do, I'm gonna consider every single number here in the bit as a weight, and I will multiply it to the dedicated what? Digit value or weight, basically. So let's do it. So gonna be here 2 power 0 times 0, 2 power 1 times 1, 2 power 2 times 1, 2 power 3 times 0, 2 power 4 times 0, 2 power 5 times 1, 2 power 6 times 1, 2 power 7 times 0, 2 power 8 times 1. Right? If I start summing all of this together, I will get the final output in the decimal. Let's see. So this one is out. This one is out. This one is out. This one is out. So the only one we have is 2 power 1 times 1 is 2. And this is 4. And this is 32. And this is 64. And this is what? 64, 128, 256, I believe. Right? Because 2 power 8 is what? 2 power 7 is 128. 2 power 5 is 32. Wait, 2 power 5 32. 2 power 6 is 64. 2 power 7 is 128. 2 power 8 is 256. Yes. So if you add this number together, so it's going to be what? 2 plus 4 is 6 plus 64. You're talking about 70. 70 plus 32. You're talking about 102. 102 plus 256. So the total will be 853. So the question here is, this number is the same number we have from the beginning?
Yes.
So what does it mean? It means that, you know, the conversion process we made is correct. Sounds easy?
Wait, I'm so confused about the beginning, the 1011001102.
We will
Sorry, I
make
just-
more,
I
we
don't know
will
where I
make
lost
more, let's make more examples, you know, that's why I'm here to help, right? So what other example we can make? Let's try to make something more simple, right? So let's make it 128. So I have 128 in decimal, right? And I'm looking for the equivalent of it in what? In a binary. Okay? So what is the rule? Here is the binary, right? So that means every number I have, I'm gonna start dividing by this value, right? So 128 divided by 2. What is the value will be?
64.
64 plus 0, 2, right? This is the Q, this is the R, right? Now 64 is equivalent to 32 plus 0, 2. 32 divided by 2 is 16, 0, 2. 16 divided by 2 is 8, 2. 8 divided by 2 is 4, 0, 2. 4 divided by 2 is going to be 2, 0, 2. 2 divided by 2 is going to be 1, 0, 2. We cannot close until we see half, so going to be half. It's going to be here. We see here in the quotient 0, we are done. Right?
Okay, so from this, how do you go to the 1011?
Okay, so I go from the top to the bottom because I'm targeting right to the left.
Okay.
Okay, so let's do it now, right? This is the digit 0, right? So 0. Second digit, third digit,
Oh, okay. Okay.
fourth digit, fifth digit, sixth digit, seventh digit, and the last digit. So this is our equivalent to 128. Sounds good?
Yeah.
Any questions so far? Hello?
That's great. Thank you.
Super. Now, we need to check how can we do the fraction, right? How can we do the fraction? So the fraction is a little bit different. So the fraction, you multiply the fraction. So you can think about it like this, I have a number here and whatever point, because by the way, don't forget, this is called decimal point. In the binary, it's called binary point, right? In the hexadecimal, it's called hexa point. It's not decimal anymore, right? So whatever and the point and whatever, right? So now this is an integer, this is a fraction. Here we set up the rule on, whatever we're gonna convert to, we're gonna use the base and we keep dividing by, and we look to the remainder, the nominator of the remainder, and we just collect it from the left to the right, which is basically the top to the bottom, right? Look at the fraction. The fraction is the reverse. Instead of dividing, you're gonna multiply. And then instead of reading from the top to the bottom, you're gonna read from the bottom to the top.
Okay.
That makes sense?
Kinda. I think so.
I will tell you why it makes sense. Because here we will just lower to the higher, right? There that was the higher to the lower, right?
Okay.
Think about it. If there was here 1, right? Of course the value, it will be higher than if I have here 1 and 0. So
Okay.
it's reversed, right?
Yeah.
Now make sense?
Thank you.
You're welcome. So let's try a number. So if somebody tell you, let me pick up like an example or problem from the book. Should I do it with binary, or should I do it with some other systems? Which one is more convenient to you guys? Should I start with binary first, or should I do it with any other system?
Is the binary system easier?
It's whatever. It's just a use case.
Oh, yeah, sure. That's fine.
Do Octal.
Whatever is more
Yeah,
convenient to you guys.
Octal sounds good. Octal or Hex?
Okay, so maybe we can try with Octal. So let's say that I have 0.513 in decimal. Now it's a fraction, right? And I want to convert it to what? Something in octal. So we said in a fraction, we're gonna multiply with the base. Here's my base, right? So in that case, I would say, okay, so I'm looking for 0.513 times 8. What the value would be? So 0.513 times 8. So gonna be a 4.104, right? What will be the next step? Imagine what's the next step. Next step, it will be taking the fraction and you multiply it again with 8. And that will be a value. That will be our golden egg. We are looking for mining it. So this is basically going to be 0.104 times 8. So the value will be 104 times 8. So going to be 0.832. Then I take this, and I say 0.832 times 8. So they're going to be 6.656. Then I take this into 0.656, and you will continue. Guess you're going to continue to what? Forever, if you want, or up to a certain digit. That makes sense? Forever or up to a certain digit. It's up to you. It's up to a certain digit. So in that case, I'm sorry. So that will be a value of 6.56. So 0.656 times 8, so going to be a 5.248, and you can continue. So now, have you noticed something? All the number comes to you for 0, 6, 5. All these numbers below 8, below 7, which is actually the highest number in the octal. The octal 0 to 7, right? So in that case, if you would like to write the equivalency, you can come and say that, 0.40 1 second 0, 6, 5, and you continue like that. Does it make sense? To make it more easy, I can practice more examples. Let's make it today just practicing a lot. Because, this is important stuff. Once you understand how to move from binary to decimal and system to the other system, it will be very easy for you to understand the rest of the course.
Professor, so if we're converting from base 10 to base 8 on refraction, do we just go to like the third digit, or do we just keep on going?
We continue. Whatever, come to you.
Okay.
Let's say that, I'm asking to you, converted with respect of the first digit. Then you will just continue the process to 4 digit.
Oh, got it.
With respect of the 8 digit. If I keep it open to you, just make, your reasonable thing,
Got it. Thank you.
You're welcome. So anyway, now let's actually combine them together, right? So if somebody tell you that, I have a number, and this number is 1054.18, and that's in the decimal, and I would like to convert it to a binary. So what I'm gonna do it in the 2 parts, right? So I have here a binary point, and I will take 2 pieces, right? Do you guys agree? The first piece is gonna be 1054, and I will start dividing by 2. So it's gonna be 1054 divided by 2. What the value will be? 1054 divided by 2. So it's gonna be 527 plus 0 divided by 2. So 527 divided by 2 is gonna be, there is a fraction here, so it's gonna be half plus 263. 263 divided by 2. 263 divided by 2. So it's gonna be 131 plus half. Then 131 divided by 2 is gonna be 65 plus half. 65 divided by 2. 32 plus half. And then 32 divided by 2. That's going to be even. So it's going to be here 0, 2. And then 8. Scheiße. It's going to be here 8 plus half. And then 0. I'm sorry. 8 divided by 2 is going to be 4. And then 4 divided by 2 is going to be 2 plus 0, 2. And then 2 divided by 2 is going to be 1 plus 0, 2. Then 1 divided by 2 is going to be the half plus 0. We stop, right? So what I did now, I did the process to convert the integer to a binary, but we haven't finished yet, right? So in that case, I can say here it's 0, 1, 1, 1, 2, more 2 ones, and then 1, 2, 3, 4, 5. So 5 zeros. 1, 2, 3, 4, 5. And then 1. Right? The second part of the question, 18. So I will take 18 and I will multiply it by 2. Multiply with 2, I'm sorry. So you're going to be here 0.18 times 2. What the value will be? 0.36. 0.36 times 2. So going to be 0.72. 0.72 times 2. 144. 0.44 times 2. They're going to be 0.88. And then, 0.88 times 2. So going to be 176. And you continue, right? Collecting this. So your 0 is going to be here. Your 0 is going to be there. Then I have here 1 and 0 and 1. 1, 0, 1. And then, after that, I would just have what? Bunch of dots like that. So what I did now, I completely converted the real number represented in the decimal form to a real number represented in the binary form.
Professor?
Yes.
So if I heard you clearly, that means when converting like decimals, we can just stop anywhere unless you tell us straight up, okay, I want you to get to the 16 or the 17 value.
You mean here in the fraction?
Yes.
Yes, I mean, you stop, it depends on, either that I'm gonna request from you to stop, like you say, that with consider of what number of digit, or you do it by yourself, you decide.
Okay.
Normally, because, we are here in engineer. So basically, I leave it to you. Because in engineering, you have to learn something. First rule in engineering, sometimes you have to assume stuff. It's not like, I will give you everything. Sometimes, I trick and I say that, I let you decide what you're going to do. Okay? So far, so good? Any question? Yes, sir. Hello?
Sorry, no, I said cool. This is what we were talking about before.
Which one? I mean, about this part?
Oh, sorry, never mind. Sorry, I'm good. No question.
Okay, super. Okay. Anyway, so we learn how to move from something to something, right? We learn from the decimal to binary, binary to the decimal. I did an example of the octal. That means you can do it also with others, right? Let's say that I like to do decimal to what's called decimal to hexa, right? 128 in decimal. I wanted to get the equivalency in what? In hexa. So in that case, I will divide by what?
16.
Yes. So going to be 128 divided by 16. What is the value will be? So 128 divided by 16. So going to be 8 plus 0 over 16. Then 8 divided by 16, and you will continue. Right? So it's going to be here 8 divided by 16 and 0. Then you can say it's 80. And you continue. Okay. Now, there is some other things we need to learn, which is how can we deal with binary to hexa and octal and the vice versa. One of the way to do it is to back to decimal, and from decimal you do the trick. The other way to do it is actually to do something called grouping. So you will do something called grouping. So imagine the following. Imagine somebody telling you, I have a number like this. in a binary, and I'm looking for the equivalency in what? In octal. What should I do? And there is a little bit trick. Okay, what is this trick? Have you guys used the logarithmic function before?
I haven't.
Okay, so I can help you with that. So if you look to 8, right? Log 2 of 8, what is the value is?
3.
3. Because it's actually log 2 over log 10. It's basically, you can write it like this, log 10 of 8 divided by log 10 of 2. If you don't have log 2, right? In the calculator. So anyway, it's basically 3, as you said. So what does it mean? It means that, you know, 1 digit in octal can be represented in 3 digit in binary. This is the octal and this is the binary. Make
Wait,
sense?
say that again?
Huh?
Sorry, can you repeat that again?
So it means that, you know, 3 digit of octal will be translated to, 1 digit in octal can equivalent to 3 digit of what? Binary. Let's approve it. Let's approve it. Let's see what, you know, if I'm saying correct or not. So, you know, octal is 0, 1, 2, 3, 4, 5, 6, 7 per digit, right? If I look to it, to binary, I want it to be a binary. What should I do? I will keep dividing by 2, right? Do you guys agree? So you will find out that 0 can be 1, 2, 3. 1, it can be 1, 0, 0. 2, it can be 0, 1, 0. 3, it's going to be 1, 1, 0. And 4 is going to be this number. 5 is going to be that number. And 6 is going to be 1, 1, 0. And 7 is going to be 1, 1, 1. So literally, every single digit in an octal is represented in what? 3 digit of what?
Binary.
Binary. Let's play the game more and say that let's go for hexa, right? Hexa, so log 2 of 16. So we are talking about what? 4. Yes. Let's look at the hexa. Hexa, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for me is A. A, B, C, D, E, F. So if I make a fancy table, right? So 0 will be what? 4 zeros. Then you will start putting 1 here, lower, right? Because 2 power, don't forget, right? This is actually the 2 power 0, 2 power 1, 2 power 2, 2 power 3, right? Same thing we did with the weighted system, right? So here's 1, 0, 0, 0. 2 is going to be this, right? So going to be 0, 1, 0, 0. 3 is basically this and this together. So going to be 1, 1, 0, 0. 4, it's actually 2 power 2. So going to be 0, 0, 1, 0. 5 is actually 2 power 2 and 2 power 0. So going to be 1, 0, 1, 0. 6 is basically this 2 combined together. 7, 3 of them together. 8, 9, 10, 11, 12, 13, 14, 15. Does it make sense?
Yeah.
So if you want to go from hex to binary, you're gonna take every single digit and you break it into 4. If you are in a binary and you want to go to hex, you're gonna combine every single 4 and you will just represent it in 1 digit. Let's practice, right? It's just a fun of practice, right? So let's say my example as follows, right? I have an hexa value, which is basically A, C, and the hex point, and then I have F, D. And I want to convert it to the binary. So one of the way I would do it, which is very straightforward, C from this lovely table is 0011. A is basically this value, 10. Then I have the binary point now, and then I will go to F, which is 1, 2, 3, 4, and then I have D, which is basically 1, 0, 1, 1. So this is the equivalency in a binary to whatever written in hexa. I didn't go through the decimal. Make sense? Somebody wants to see the octal chart. 1 second. Here. Alejandro, can you see it? So it's the same thing, right? And now it can be even more tricky, right? If you are hexa and you want to go to the octal, what are you gonna do?
We do the same thing. We take the logs and then divide them and then figure out the power.
It's gonna be how many digits? Huh? It's gonna be log 8, 16. So 2 digits.
Yeah, so I'm slow.
Exactly. So, relation between hex and octal is log 8, 16 equal to. Let's do it, right? So I have here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, right? So 2 digits, right? So 0, 0, 1, 2, 3, 4, 5, 6. Our top value 7, right? Now we're gonna start incrementing. Like, do you remember when we are in decimal 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you will do what? 0 and 1, and then you will continue, right? Same thing. So gonna be what? 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1. That makes sense? So every digit in hexa represented in those in octal. And this is 8 power 0, 8 power 1. Right? Let's pick up one on the table and see whether that's gonna give me a correct value or not, right? Let's take this 1, 1, right? So it's 8 power 0 times 1 plus 8 power 1 times 1. What is the value? This is 1 plus 8 is equal 9. 9. Any question?
Sorry, can you do A? So if you do A,
Huh.
so if you do A, it'll be 1 times 8 power 0, and it'll be.
Let's do A. Yeah, let's do A. You're right. So gonna be 2 power.
Yeah. 2 times 8 power 0. Yes.
1 times 8, 1. So the value is what? This is 2 plus 8 is actually 10, and we know 10 is A.
Gotcha. All right.
Yeah.
Because we cannot just say 10. 10 is gonna be 2 digits,
Yeah.
right?
Yeah. Got it.
So make it hidden like this. 10 is A, 11 is B, 12 is C, 17 is D, 14 is E, 15 F. Right? Have you noticed it's just playing, we are playing with numbers. We are just playing with numbers, right? Let me give you some practicing also. We can do it now and we can check the book. If somebody's telling you I have 6, 7, 3, 1, 2, 4 represented in the octal, and I want it to be converted to something in binary, what I'm gonna do? So with respect of this log to whatever, right? So every digit gonna be broken up into what? 3 in a binary, right? So my 4 will be 0, 0, 1. My 2 is 0, 1, 0. My 1 is 1, 0, 0. And then you know my binary point. My 3 is 1, 1, 0. My 7 is 1, 1, 1. My 6 is gonna be what? 0, 1, 1. And this is the representation of the value here written there.
So, Professor,
Yes, sir.
so like when we're converting from octal to binary, you can kind of think of it as that to represent the smallest bit in octal, you need at least, or with 1 bit from octal, to represent the largest number with 1 bit, you need 3 bits from binary to possibly represent it. Okay, and then 4 if you're trying to use binary, going from hexadecimal to binary.
Yes.
Okay.
Just do it like this. I want a relation between hex and binary, right? And then I will just say log the binary, and the value is the hex. So that means any digit in hex equal 4 of the binary. If I would like to do it like this, octal with binary, log is gonna be 2, 8. You're talking about what? 3. So any digit of octal will be represented by 3 digits of what? Binary. Let's make it like this. I want hex and octal relation. So log 8, 16, 2. So any digit of hex will be equivalent to 2 digits of octal. You group them or you break them. It depends on which way you are going into. That makes sense? Is it easy peasy lemon squeezy? Another example, 30D. No, the BP 06, and the hexa point, and we are into the hex. Some of the notation of books we just write it hex like this. Some of the notation will just make it 16. Okay. I want this to be translated to binary. So what I'm gonna do, D should be broken into a 4 digit of binary, right? What is D? E is 14, D is 13, right? So 13, that means 2 power 0, 2 power 1, 2 power 2, 2 power 3, right? So it's gonna be 1101, I believe. So it's gonna be this one. So you're gonna put it like that. So 1101. Your point. 6 is what? Then 0, then 3, and this is our equivalency of that one. So it is a matter of what? Practicing. It is a matter of practicing. There is actually, if you guys actually have a copy, I already give you a link for the book, right, on Slack. If you open like a page.
Sorry, Professor.
Yes.
Do you need 4 zeros in the middle?
Wait a second.
Do you need for the 0, like 306, the 0? Isn't there supposed to be 4 zeros?
You are right. I'm sorry. I made a mistake. It should be not. Yes, you're right. You know, when I made it like that, I thought it's octal in my head. So you're right. Thank you. Okay.
So
There is a very nice, there is a very nice table you will find in the books, by the way. In the book you will find it. It's showing you decimal to binary, octal, hexa, and back and forth. Yes.
all these different values and everything, are we supposed to memorize all this, or is it just
you
like
don't need to memorize, you know, it's just, you know, tricks, right? So for instance, you know, I won D, right? What is D is?
What is D?
You know, if somebody's telling you convert D, for instance, I'm just giving an example, right? You don't need to memorize, you just need to know the trick, right? I know it's a hexa, right? And I know D sorted in the what? In the location after A, B, C, D, right? And A is 10. So basically B is what? 11, C is 12, you know, D is 13, right? So I know 13 is basically what? You break it up into a binary system. So basically you already have 2 power 0, 2 power 1, 2 power 2, 2 power 3, right? And I need 13. 13 is gonna be what? 1, 1. And then, you know, I have here 0 and have here 1.
Okay.
You understand?
Yeah. Thank you.
It's just a matter of playing with the number that, you know, we started from the beginning by this divided by 2, multiplied by 2, and so on. You will get used to it eventually. Any other questions? Tell me if you have any question.
Just absorbing the information right now.
I'm not gonna bump you with a lot of information today. Let's take it step by step, and then, you know, after that we'll speed up. Okay. What is the golden advice I can give you? Practice any number with any number, and you try it back and forth. Do you remember when we tried with 358, and then, you know, I came from binary, I push it to decimal, and from decimal back to binary to check whether that, you know, it's a bi-reversible. Same thing. Let me find you one more example, since it's already 2 o'clock, so we still have 15 minutes in theory, but in reality I will give you 5 more minutes, and then, you know, you can guys take some rest before you will move to the next lecture. Let me find you a nice. Okay, if somebody's telling you, here is my value of 101100001 101.11, and here is my binary, and I want to convert this to what? To octal and hexa. Let's try it, right? Nothing will hurt, right? So how can we do it? If I want it to be octal, I would start grouping, right? So grouping, those are together. Those are together. Those are together. You will ask me, there is nothing here, right? You can put 0. You can add zeros to infinity, right? Nobody will, it will not affect, right? Then, you know, I can just go in the other side and just do same trick here. Those together, those together, those together, those together. Right? So now I'm checking the value to group it, right? So here is my octal point. This is what? 2 power 0, 2 power 1, 2 power 2. So you're talking about what? 3. Same thing here, gonna be 5. Same thing here, gonna be 1. Here, 2 power 0, 2 power 1, 2 power 2. You're talking about 6. Here, 2 power 0, 2 power 1, 2 power 2. So you can talk about 2, right? There, 2 power 0, 2 power 1, 2 power 2. So you're talking about 7. Here, 2 power 0, 2 power 1, 2 power 2. You're talking about what? 4. Here, 0. Here, it's gonna be 6. See, this is basically my 8. Right? Let's take the same one and make it what? Hexa.
Okay, yeah, sounds good.
Now
So you
this
just
bit-
group it into 4?
Huh?
You just group it into 4?
Yes, exactly. So this grouping that I made up here, it will be changed. So I have to write it again. 1 1 0 1 0 1 1 0 0 0 1 1 0 1 0, and then put it here 1 2 3 4 0 0 1 2 3 1 1 0. Here's the same binary, right? Now we're gonna group, right? First patch, second patch, third patch, fourth one, and you put here 0, of course, right? Same thing you did here. So look, it's gonna be here 1 2 3 4, 1 2 3 4, then luckily 4, right? So I go here and say point. This point is gonna be for me what? It is hexa, right? So hexa point. So gonna be here F, here 0, and here 6, and there is gonna be what? D. This is 6. This is 12. 12 is C, and this is 2, and this is my hex, or you can write it whatever as notation. Sounds good?
Yep, practice, practice, practice.
Exactly. That's exactly what I was telling people in the last semester, practice, 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 practice. When you get tired, just go practice. Yes.
Would the 1011 be D or would it be B? Because isn't that
It is
11?
actually not correct. It's not D. You are right. It's basically B. One of the things I really like is to make mistakes. You know why? So people can correct me. And if they correct me, that means what? They are following me. So thank you.
So is the best way to do it just by memorizing it?
Did I memorize anything in front of you? I just know the only thing I know is basically the 2 power whatever. I know the digit. So the best way to study is basically in the decimal. 10 power 0, 10 power 1, binary, 2 power 0, hexa, 16 power 0, octal, 8 power 0, and you will move forward. You just play with relations between numbers.
I think the more you do it, then it'll be like memorized pretty much. Like
It is a kind of a
10,
dynamic
10 is
memorizing.
A, yeah, 10 is A and 11 is B. Just 12
Yeah,
is
I mean,
C.
over time it will hit in your head, yes.
Yeah.
But then you will leave it, you will forget it, but still when you will scan it again, you will remember, and so on. That makes sense. But I like rules and regulation. Like, look, this log 2, log 8, log 16. All of these things are gonna make it easy for you. Make sense? Anyway, since it's already 2:07, so I will give you an 8 minutes for relaxing and preparing for your next class.
Wonderful.
So if you have any questions, please let me know, and I will be more than happy to assist you. A copy of this recorded lecture will be posted on the Blackboard under the week 1 recorded lecture. Do you want me also to put a copy of this handwriting notes? Handwritten notes?
Yeah, that'd be great.
Yes.
Thank you.
Yes, I'll do that. Okay. So in front of you before I forget, because I forget stuff. So anyway,
Professor, are you going to be putting up any like practice problems soon on Blackboard, like homework?
Yeah, I can tell you what is the practice you need to do, right?
Okay.
The practice you need to do, practice. Just bring any number and any number, and
Just any numbers. Sounds good.
any number. You can imagine any
Right.
number. This is the best way to say. Any number of any number.
Got it.
And then we'll just practice it in class, kind of thing.
Yes, and also just look at this, and any number of any number. And by the way, don't forget, by the end of the chapter 1 in the Mano book, right? You will find a ton of examples. I'm sure about it. Let me go check now. That's chapter 1. Let me see. Yeah, they have a ton. Look, problems, for instance. Here, do you guys have 1 minute to do? Or that's fine. One of the questions here is convert the following number with the indicated basis to decimal. And the guy actually having a fantastic number, Let's say 198 and the base is 12.
Whoa.
It's super cool, right? Because what are you gonna do? You're gonna divide it by what?
Divided by 12. Or divided by 10?
If
Wait,
you
you said
do it with
decimals?
binary, you divide it by 2. If you do it
Oh.
with decimal, you divide it by 10.
Yeah.
Right? Come on, it's not really hard. It's a piece of cake. Okay? Okay, guys. So God bless you. Stay safe, and I'll see you on Monday. Okay? Thank you.
Thank you, Professor. I appreciate it.
I appreciate you.
Have a good one.
You too. Thank you. God bless you.
Thank you, Professor. Have a good day.
You too. Thank you. Thank you.